Here we go. This wonderful announcement again. The following Zoom session is being recorded and will appear later today on my YouTube channel, Math with Mayo. There are 2 different classes that may be observing this session. Therefore, when you participate in the Zoom meeting, if you do not wish for your picture or your name to be made public, please leave the video off and use an alias name. If you have questions during the meeting but do not wish to speak, email me at bmayo@ybcc.edu and I'll respond as soon as I can. So today we're going to cover section 8.3 and 8.4. Before we do that, are there any questions from yesterday's 8.2 that you would like me to deal with at this time?
Yes.
Okay, what do you got?
Number 13.
So this is from 8.2 part 1 or part 2?
Part 2.
Part 2, number 13. Okay, Jamie, give me a minute here and I'll pull that one up. Okay, let's see here. All righty. Here we go. All right, you said 8.2, part 2.
Number 13.
Gotcha. Okay. All right. So here it is. Okay. Can I get you to go ahead and turn off your sound mic?
Sorry.
Coming through. No, that's okay. That's okay. And then if you have questions about what I'm doing, turn it back on. But there's background noise that just stresses some people, not me though. Okay, a software company has found that on Mondays, the polynomial function, blah, 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 approximate the number of callers on its hotline at any time. Here, T represents the time in hours since the hotline opened at 10 a.m. How many service technicians should be on duty on Mondays at noon if the company doesn't want any callers to the hotline waiting to be helped by a technician? So basically what they're saying is, how many technicians do they need 2 hours after they open? Okay, it opens at 10 a.m. and we're talking about noon, so that's 2 hours later. So what they want us to find is C of 2. In other words, time, T, is going to equal 2 hours. Okay, so
I got the 2, but,
okay, but
I didn't get the question right.
Okay, well, let's take a look here. Oh, it shows you came up with 9. Okay, let's see what's going on. Okay, so 0.0625 times 2 to the 4th power plus 2 to the 3rd power minus 6 times 2 squared plus 16 times 2. Okay, so let's take a look at the whiteboard. We've got, did I copy that correctly? Yeah, okay. So then this becomes negative 0.0625, 2 to the 4th power.
I think I copied down the problem.
Copy the numbers wrong?
Yeah, somehow I wrote down I wrote down 0.0625 t to the 4th minus 6t to the 2nd.
Ah, so you left out that t cubed. That'll do it. That'll do it. Okay. All right, let's see here. So I'm going to go to my handy dandy calculator, and I've got negative 0.0625 times 16 plus 8 minus what, 6 times 4, 24 plus 32, and I get 15. So 15 technicians. Yeah, so you just left out a term when you copied it down. That'll happen. That'll happen. Okay, anything else while I've got this up?
Thank you.
You bet. Anybody else, any questions about yesterday's assignment? Okay, so now we're going to do, it always makes me nervous because I'm going to switch to a different screen. And even though I will try it out ahead of time and everything works just fine, then I'll come in here during class and for whatever reason, sometimes it won't work. So let's see what happens. Okay, can you all see on your screen, it says 17a, f of -2?
Yes.
Okay, great. Now we'll see if I can write on the screen all right. Here we go. So what we've got over on the right side, we've got a picture of a function labeled as f, okay? It's a linear function, it's that straight line, okay? Here, we should have a scale on there. So this is like 5 and 10 and -5 and 5 and -5. Okay, now, we are asked a question, okay? This question right here, it says 17a, f of -2. What they're saying is this: for this graph of f, when there's an x value of -2, what is the corresponding y value? So what we need to do is on the graph, locate the x value that is -2, and that would be right there. So there is a point that has an x value of -2. What is the corresponding y value? It's -5. So f of -2 equals -5. That is to say, the point -2, -5 is on that graph. Any questions?
How are you getting -5?
I'm not. I screwed up. It should be -4. My bad. That's how I'm getting -5. Sorry, I'm too stressed about, is this going to work? Is this going to work? That's poor excuse. How's that? Is that better?
Thank you.
At least that shows that you understand this, maybe better than I do. Okay, awesome. Next question, f of 0. So on the graph, find a y value corresponding to the x value of 0. Where is x equals 0? Right there. What's y there? What's the corresponding y value? I was going to let you do it, then I couldn't screw it up. It's also 0. Right there, the origin. When x is 0, y is 0. We okay with that? Nobody's saying anything. Are we understanding or are you lost?
Are you doing a problem on one of the homework assignments or?
This is actually a problem out of the book. Why?
Because I wasn't sure what the problem is.
Oh, the problem is this graph. So it's saying for this graph, what is f of 0? So on this graph of f, when the input x is 0, what is the corresponding output? And that is also 0.
Okay.
Does that make sense?
Yeah.
Let me ask you a couple other questions that aren't on here. What would f of 2 equal? Well, x is 2 is right there. Oh, that would be 4. What would...
Okay, yeah, I'm getting it now.
So, yeah, okay, we good? All right, now,
Yep.
those first two questions were given the input, the x value, what is the corresponding output? The next two questions, part C and D, it says, what is the value of x for which f of x is 4? In other words, what input, what x value gives us a y value of 4? So basically, we're completing for C, this ordered pair, for D, this second ordered pair. So now f of x equals 4, y equals 4. Where is y equals 4? Let's see here. Y equals 4 would be right along, oops, sorry about that, right along this line. Oh, right there. So for what value of x is y equal to 4? For x equals 2. So on the graph, find the point that has a y value of 4. There it is. What's the corresponding x value? 2. We okay with that? All right, problem D is the same thing. On the graph, find a point that has a y value of -2. There it is. What's the corresponding x value? -1. All right. Any questions about that, folks? Anything there? Okay, here we go. Next problem. Same idea. Now this is the function s. They want s of -3. So when x is -3, what is y? Well, let's see. -3 for x is right there. So what's the corresponding y value? What is it? Anybody?
+2.
Excellent. Okay. See, by making you answer, then I don't say the wrong thing like I did earlier. That's my safety guard. Okay. Next question. Find s of 3. All right. So where on the graph is y equal to 3? Oh, there's that value and there's that value. So that would be, let's see here. Wait a minute, I'm screwing up. I switched over to the y values. See, that's why I shouldn't be doing this. Okay, let's go back here. All right. I was switching it around. I was fine. Okay, when x is 3, what's y? Four. Okay, so there's a point on the graph whose coordinates are -3, 2. That's right there. There's a point on the graph whose coordinates are 3, 4. That's right there. Okay. Now, part C, that's what Moses did, part C. Okay, the values of x for which s of x is 0. So what are the values? Notice it says values of x for which s of x is 0. Well, s of x is like y. So let's see. Oh, right there and right there. Oh, and right there. So there's 3 x values, 3 inputs that have an output of 0. So x equals, let's see, -1, x equals 1, and x equals 5. So there are 3 inputs that have an output of 0. In fact, those 3 points are x-intercepts. Remember, an x-intercept cuts through the x-axis. So this function has 3 x-intercepts. We okay with this? All right. The values of x for which s of x equals 3. And that's the one I was trying to do earlier when I shouldn't have been there yet. So that's this right there and right there. So what, 2 and 4? So x equals 2, x equals 4. So there's 2 inputs that have an output of 3. So all we're doing is finding points on the graph given one of the coordinates. The first two questions were given the input, the x coordinate, the independent variable. The second two questions we're finding we're given the output or the dependent variable, and we're finding the inputs or input depending. Okay. Next question. Let's see here. Another one of the same things. G of -2. All right. So the input x is -2, which would be right there. What's y? Two, right? Because that point right there is -2, 2. So when x is -2, y is 2. Okay, g of 0. When x is 0, let's see, when x is 0, y is also 2, isn't it? You okay with that? All right. The value of x for which g of x equals 3. Oh, g of x equals 3, that's right there. So what's the value of x there? That's -1. So x equals -1. The values of x for which g of x equals -1. Okay, well, let's see. Oh, there and there. So that's what? X is -3 and x is 1. X is -3 and x equals 1. Okay? Same old stuff. All right, here we go. Now something a little bit different. It says, find the domain and range of f. All right, domain would be all of the inputs, all of the x values. All right, so the domain, well, let's see. This arrow implies that this thing keeps going down, and this arrow implies that this thing keeps going up, right? As we go to the left, this thing is going down, but it's also going over, isn't it? As we go to the right, this thing is going up, but it's also going over. So as it continues up and over and down and over, eventually it's going to go to negative and positive infinity. So your domain is all real numbers. In other words, if I plotted that entire line, not just with the arrows, but extending it, and I looked at all of the input values, every real number would be considered. What's the range? The range is the same thing, because this is going down forever and it's going up forever. So the domain and the range for this function is all real numbers. Any x value you put in is going to give you a real y value. Any y value you put in that's real is going to give you a real x value. Okay? And this may be a little clearer as we look at some, for instance, this one. Okay, so here, again, this thing is going up and over. This thing is going up and over. So it's going to continue to negative and positive infinity. So your domain is going to be all real numbers. But the range starts at 3 and goes up from there. So the range is going to look like that. It's going to include 3. I can draw a better infinity symbol than that, I think. Okay, all right. So the bracket means that 3 is included. So the smallest range value, the smallest y value is 3, excuse me, 3. And then from there, it goes up. Are you okay with that? All right. Find the domain and range of f. So here, this is an end point. And then it's going off to the right and it's going down and it's going over. So the domain starts at 0 and goes to infinity. There are no points on that graph with an x value that is less than 0, because that would have to be over here where the x values are 0. Okay. What about the range? Well, the range is no larger than 0, but goes from negative infinity to 0. Now, when you're using interval notation, which is what I'm doing, we talked about that briefly yesterday, you always have the smallest value on the left and the largest value on the right. So for instance, if I were to write this for the range, that would be nonsense. That wouldn't make any sense. It has to go from the smallest, which is negative infinity, to the largest, which is 0 in this case. So even though the arrow is pointing this way, we think of the range as going from smallest to largest. The domain goes from smallest to largest. Okay, so the domain, smallest to largest, the range, smallest to largest. All right. Next example. Okay, now we're going to kind of mix the two ideas together. First of all, find f of 1. So f of 1, when x is 1, y is 3. Okay, so this point right here is 1, 3. When x is negative 3, y is 1. Because this point right here is negative 3, 1. Okay. The values of x for which f of x is 0. So what are the x values when y is 0? Well, y is 0 right there, and there, and there. So that would be x equals, let's see, negative 4, x equals negative 2, and x equals 0. Okay, now what about the domain and range? Well, this thing's going up, but it's also going over. This thing's going down, but it's also going over. So here your domain and range are once again going to be all real numbers. Okay. Questions on that one? All right. More of the same. Find g of 1. So g of 1, when x is 1, y is 2. G of negative 4. When x is negative 4, y is negative 5. Oops. It's acting up on me. I hope that doesn't mean it's going to go bad. Negative 5. Okay. The values of x for which g of x is 4. Oh, that's up here. Oops. G of x is 4. Let's see, that's right there. And then right there, which is what? X is negative 2, x is positive 2. X is negative 2, x equals positive 2. Those two inputs have an output of 4. Okay. Domain and range of G. Okay. Domain, as this is going down, it's also going over, right? So it's eventually going to go to negative and positive infinity. So your domain is all real numbers. But the range only goes up to what? 4? So it goes from negative infinity up to and stops at 4. All righty. Let's see. Okay. Just a second, I gotta turn the page to look at the instructions. It says this. Determine whether or not each graph is the graph of a function. If it is not, find two ordered pairs where more than one value of y corresponds to a single value of x. All right, we're going to talk about something called the vertical line test. Okay, now, if this is the graph, if this thing here is the graph of a function, that means that for each x, there can be only one y. If I go across this graph and I just kind of draw a bunch of vertical lines, okay? If any of those vertical lines cut through the graph more than once, it's not a function. For instance, right here, that vertical line represents x equals 1. But when x equals 1, y is 2 and y is negative 2. So 1, 2, and 1, negative 2. Those are two ordered pairs with the same input but different outputs. So again, this is called the vertical line test. If I can draw any vertical line through the graph and that line cuts through the graph more than once, which it does here and here and here and here, that means it's not a function. And what they'll say here, it says, let's see. If it's not a function, find two ordered pairs where more than one value of y corresponds to a single value of x. So I listed 1, 2, and 1, negative 2. Okay, there's others. There's lots of them there. Okay, now in WebAssign, you have to be careful because they're going to list some specific choices. So you need to find ordered pairs that they list that are in fact on the graph that violate this vertical line test, that show, oh, no, one person has 2 birthdays, one input has more than one output, not a function. Okay. Where's the mouse? There it is. Same question, is this a function or not? Now, filled in circle means that point is included. Open circle means that point is excluded. So in fact, right there, there's really only one point included. Likewise, right there. So this does not fail the vertical line test. It passes the vertical line test. So yes, it is a function. Okay. Now, what if we change the problem? What if, for instance, let's say this point right here had been filled in? Then it would fail the vertical line test. It would not be a function. And we would say when x is negative 2, y is 1. And when x is negative 2, y is negative 2. And then that would not be a function. Okay, but we'll just leave it like it is. All right. How about this one? Function or not? No, it fails the vertical line test miserably. Let's see, here is a vertical line that cuts through the graph more than once. And we've got, let's see, 3, negative 2. So no, not a function. 3, negative 2, and 3, negative 6. Okay, so there's a set of ordered pairs that show that one input goes to more than one output, and it's not a function. All righty, let's see. Okay. So that's all I've got for section 8.3. We're going to stop and take a break, but before we do you have any questions about any of the stuff that we've looked at so far today? Anybody? Okay, so we'll stop the recording.